All right, let's do something else. All right, so we learned that you could stretch it vertically. We learned that you could translate it up and down. Hmm. Let's do, I got an idea. I got an idea. Let's do this. Let's go ahead, make another graph, table of values, I should say. We're gonna try one more thing and see what it does. So, perfectly drawn table of values here. You guys have no idea how difficult this is to draw these. This software, I love Jamboard, but there are other tablet programs that just draw straight lines for you. Jamboard does not. I wish that was a tool that I had available. So this is x, this is f of x, and what's that? D d of x. No, I'm going to do n of x. So I'm going to do this one a little different. We're going to say that n of x is equal to f of x minus 2. Okay. And there's a general form for this. N of x is equal to f of x minus h is usually how it's written. That's an h. Usually that's how it's written. That's an h. Okay. All right. Well, the values haven't changed. So this is -1 comma -2, 1 comma 2, 3 comma -2, and then 5. Oops. Okay. So now this is going to be I might mess this up, but I'm trying to figure out an easy way to explain this to you guys. So let's try this. So n of 1 occurs or is equal to f of 1 minus h, which is 2, right? Which is -1. So I'm just plugging in wherever there's an x, I'm plugging in a 1, and then my formula had -2. But what's the value of f of -1? Well, the value of f of -1 is this -2 here. So I'm going here, and I'm going to plug in -2. So let me explain that again, because that's a little complicated. When I say n of 1, in other words, I'm trying to figure out what n is evaluated when x equals 1. Wherever there's a 1, or wherever there was an x, so this is technically the formula I'm using. Wherever there's an x, I plug in a 1. My formula says x minus 1, so I'm going to say x minus 2. And so I have 1 minus 2. What's 1 minus 2 equal? 1. What's f of 1? F of 1, -1, is what is the y value when x equals -1? That's -2. So that goes in here. Let's do another one in case you're really confused. So let's evaluate n of 3. So n of 3 occurs or has the same value as f of 3 minus 2, or f of, what's 3 minus 2? 1. Well, what's the y value when x equals 1? 2. Let's do n of 5. So n of 5 is equal to f of 5 minus 2, which is equal to f of 3. So that means we're going to go where x equals 3, right? And it'd be negative 2. Okay? Now I'm going to plot these points, and you tell me what's going on. So the first point I'm going to plot is 2 or 1 comma negative 2. So I'm going to go over 1, down 2. Then the next one I'm going to plot is 3 comma 2. So I go over 3, up 2. Then the next one I'm going to plot is 5 comma 2. So I go over 5, negative 2, right? So I've got this going on. What does it look like I'm doing to my graph? It looks like I'm shifting it to the right, doesn't it? So then my next point, if you were to guess, what would be n of 7? Well, n of 7 would be n of 7 minus 2, which is, whoops, that's f of that. F of 5, what's f of 5? Negative 2. So then I'm going to have to, I'm running out of space here. So when this equals 7, I'm back up here at positive 2. So what did I do? Well, we would say that h translates is a fancy math word that means moves left or right. So if h, but it's the opposite direction. If h, in this case, h was negative, so I would say if h, let me do a little bit better on my handwriting. If h is less than 0, that means that it's negative. If h is less than 0 or negative, it moves it to the right. If h is greater than 0, that means that it's positive, but it moves it to the left that many spaces. Okay? So to summarize this stuff, I'll give you a second to write this down, then I'm going to go to the next slide. This is all part of example number 1. Well, actually, it's example number 2. No, it's example number 1. We're going to put it all together in a second. Now, the only thing we have left to do is to transform it by stretching it horizontally. Okay. Any questions on this one? Let me pause this and stop. This